Okay, well, let's get started. It's 8:19. So here are the three rules that'll help you figure out how to approach this. So guidelines. Oops. For evaluating integrals. Involving powers of sine and cosine. So number one. When the power of sine is odd and positive, save one factor, for du and convert. The remaining factors to cosines. Then use u equal to cosine x. So that's for that type of scenario. Number two. When the power of cosine is odd and positive, save one factor for du and convert the remaining factors to sines. Then use u equal to sine x. When the powers of both the sine and cosine are even and non-negative, make use of the power reducing formulas. Okay, so this is from pre-cal. Sine squared x is equal to 1 minus cosine 2x over 2. And cosine squared x is equal to 1 plus cosine 2x over 2. Oh, 1 second. Okay. All right, let's go on to the examples. So the integral of sine cubed x times cosine to the fourth x dx. So when the sign is odd and positive, so that's going to be number 1, we will use this scenario here. Okay, so basically factor out a sign. This is what we're going to do. We're going to save an extra sign for later. So this is my sine squared x times sine, times sine x times cosine. So let u, that's what the instructions say, equal cosine x. So du will be negative sine x dx. So there is no negative sign. So negative du is equal to sine x dx. All right. So here we go. So we're going to change this into cosine. So that'll be 1 minus cosine squared using our Pythagorean times sine x times cosine. Actually, I'm going to put that sign at the end so you can see how the du is replaced. So this right here, right? This right here is your negative du. These are all going to be your u's, right? So this will become 1 minus u squared times u to the fourth times negative du. Simplify this and we'll get u to the fifth minus u to the seventh. Pull out the negative du. Right? So this would become u to the 6 over 6 minus u to the 8 over 8. So this will be, swap the signs with the negative outside. Let me double check. Oh, yeah. This should be 4 and 6. Oops. Thanks. I guess I integrated before I did the algebra there. 4 and 6. So we get u to the 5th over 5 minus u to the 7 over 7. Swap the signs because of this minus. Plus c. So change that back to cosine, and we have negative cosine to the 5th over 5 plus cosine to the 7th over 7 plus my c. So you see how scenario 1 works. Is there any questions about the first one? All right. Let's go to the next one. So the integral, this time we'll do actual limits, pi over 6 to pi thirds. of cosine cubed x over the square root of sine x dx. Okay. So I'm going to go ahead and bring the cosine up top, or the sine rather, and make it a negative 1/2 power. This is make it a little easier. So you got cosine cubed x sine negative half x dx. So which scenario would that be? Let's see here. Power of cosine is odd, so that's number 2. We will save an extra cosine for the du sub, or the u sub, and go from there. So cosine squared x times sine negative half x. I'm going to leave the extra cosine in the back because I'm going to use that for my dx. So let u equal sine du equals cosine dx. So there's my du. And I need to change cosine squared into 1 minus sine squared times sine of negative half times cosine x dx. So that would be integral of 1 minus u squared u to the negative half times cosine, times du, sorry. So multiply it out, do the integration. We will have u to the negative 1/2 minus u to the 3/2 du, which is equal to u to the 1/2 minus over 1/2 minus u to the 5/2 over 5/2. I'll put the bounds in a second when I finish the resub. So that would be the same as 2 times the square root of sine x minus 2/5 times sine x to the 5/2 from pi over 6 to pi thirds. Okay. So this time just plug it in and it'll be good. Let me double check everything. Yeah, looks okay. So this would be 2 times the square root of sine of pi thirds minus 2/5 sine of pi thirds to the 5/2 minus 2 times sine of pi 6 minus 2/5 sine of pi 6. Anyway, let's see. I think if we punch that into our machine, that's roughly 0.2385. You guys cool in example 2? All right. All right, let's move on to the next one. Example 3. So here we have a sole cosine by itself, but it's even. So we should use the power reducing. So this is the same as the integral of cosine squared of 2x squared, right? So remember that cosine squared x is equal to 1 plus cosine 2x over 2. So we're going to replace the inside with this identity. So we will get 1 plus cosine 2x over 2 squared. Now just FOIL this out, right? Distribute the square. And you will get 1 plus 2 cosine 2x plus cosine squared of 2x over 4. Separate the integral to 3 integrals, so that'll be 1/4 dx plus 2 cosine 2x dx plus, oops, I forget my 4, plus 1/4 cosine squared 2x dx. So these two integrals are no big deal. We've done that before. This one will require another power reducing. So to do it again. So I'm going to go ahead and integrate these easy ones. That'll be 1/4 x plus, that will be what? 1/4 reduces to 1/2, divided by 2, yeah. Sine of 2x. So this one will have to be changed. I'll put the 1/4 out here for now. That'll give us 1 plus cosine of 4x, because I'm using the power reducing again, dx. So those two will have to be integrated separately. These are just going to come down. All right. So this will be, so 1/4 times 1/2, that'll be 1/8 x. Integrate this guy. That will be, well, let me show the work just in case it's weird. So separate it. That'll be the integral of 1/8 x dx, right? Plus the integral of cosine 4x over 8 dx. So finally, the last integral, last step, I guess, will be this. Integral of this guy. Integral of this whole thing will be sine of 4x over 16. Now, is there any step that didn't make sense? Or any integral that was strange? Okay. You can combine some of these, right? Technically, but yeah, you can combine these two. This is 8.3. Double check something. So use the formula, squared top and bottom, separate into 3 pieces. Integral of that is correct. Integral of this is correct. Apply the formula again. Doubles that angle one more time. That'll be 1/8, 1/8. Oh yeah, that should be a 32. I knew there was something off here. This is 32. So we can add these pieces, but that's about it. Final answer, if you want to make it a little bit prettier, would be 3x over 8 plus 1/4 sine 2x plus sine 4x over 32. All right. You guys cool on this one then? We're going to move on to extra formula. Man, a lot of paper. So Wally's formula. If n is odd, n greater than or equal to 3, then use these two formulas. So the first one is this one. If you're integrating from 0 to pi over 2, cosine nx dx, that will be equal to 2/3 times 4/5 times 6/7 all the way till n minus 1 over n. So if we had a cube, you'd go out 3 terms or whatever. Sorry, 2, 3, 4. Yeah, we'll do the example in a second. Let me write number 2. If n is even and greater than or equal to 2, then the integral from 0 to pi over 2 cosine of nx dx, that will be equal to 1/2 times 2 3/4 times 5/6 all the way till n minus 1 over n, actually over n times pi over 2. All right, so this example right here, integrate from 0 to pi over 2 sine x to the 6 dx. So let's apply Wallace formula. Wallace, maybe, I forget how to say it, but who cares? So it's even, greater than 2, then we can do it. So n is 6, n minus 1 is 5, obviously. So this will be equal to 1/2 times 3/4 times 5/6 times pi over 2. So we go up to n minus 1 Let's see here. So 0, 1, 2, 3, 1, 2, 3, 4, 11, 6. Yeah, that's fine. Yeah, sorry, just making sure the way to explain this. So since it's 5, we go up to the fifth 5 here. Yeah, it's the easiest way to think about it. Anyway, that would be about, so let's see, multiply this out, you would get 5 pi over 32. We won't have very many of those types of questions, but figured I'd at least mention it. Now let's move to secant tangents and cotangent type problems. Okay, let me go to another amount of paper here. So I'm going to have to use lined paper. Okay, so here are the guidelines. For evaluating integrals involving powers of secant and tangent. All right. Number 1. When the power of the secant is even and positive, save a secant factor for du and convert the remaining factors to tangents. To basically use this. All right, number 2. When the power of tangent is odd and positive, save a secant tangent, sorry. I should say secant squared. Sorry, let's fix that notes there. Save a secant tangent, so secant times tangent factor. And convert the remaining factors to secants. let u equal secant x. Number 3, when there is no secant, factors and the power of the tangent is even and positive, convert a tangent squared factor into a secant squared factor. Basically, let u at that point be tan x. So number 4. When the integral is secant only with an odd and positive exponent, use integration by parts. I'm trying to give you all the scenarios, so if you get stuck, you know what to do. Final one. If none of the above apply, convert to sines and cosines. Okay. All right, so let's do an example 5. One second. Okay, here it is. Integral of tangent cubed x over the square root of secant. Okay. So we said earlier, well, first let's rewrite this because that looks weird. That's tan cubed x times secant negative 1/2 x dx. Okay. All right, so let's look at our properties. So we should probably use, we have a positive secant power, or sorry, positive tangent power, and it's odd, so it should be number 2. Yeah, so we'll break off one of them and save it for the substitution. So over here, I'll have an extra tan waiting for the sub. All right. Now, we know that tangent squared is equal to secant squared minus 1, right? Using our trig identities from way back when. So we let u equal secant. Actually, secant, let me think here. Oh, shoot. We probably need to save a secant tangent. Yeah, well, we'll see what happens. We'll just wait. du would be secant x tangent x dx. Right? Multiply this out. We need that secant tangent. We only have a tangent. So what I could do, it's a little weird, but I could do this, is pull out a positive secant from here, which would make it more negative. You see what I mean? That weird? You see how these two is the same as this, right? Let me lower the brightness a little bit. Any question about that so far? Okay. All right, so if that makes sense, we're going to multiply this in. That'll give us secant 2 plus 2 minus 3 halves would be 1 half x minus secant negative 3 halves x, right? And then we'll leave the secant x tangent x for the sub. So here we go. This will become u to the 1 half minus u to the negative 3 halves times du. Right, no big deal. So now integrate that, and you'll get u to the 3 halves over 3 halves minus u to the, let's see, plus 1, negative 1 half over negative 1 half. All right, so resub and we're done. So this will be 2/3 secant 3 halves plus double negative cancels, giving you a secant x 1 half plus c. All right. Any questions on this problem? Okay, let's do one more and then we'll go to a different section. Also, I need to check. I need to extend your homeworks. I think some closed, right? Forgot about that. So secant x over tangent x. All right, that's a tangent squared, actually. All right, so here it doesn't look like any of the properties will help us. And I'm not going to do by parts because that would be silly. But I see stuff that could cancel because I have a secant and a tangent. Because technically this is the same as saying secant x times 1 over tangent squared x dx, which is the same as 1 over cosine times cotangent squared, right, technically, which is really just 1 over cosine times cosine x over sine x. So these are gone, leaving me with oops, that should be squared. So I'm leaving me with cosine x over sine squared x dx. So at this point, we could just do a basic u sub, right? Let u be cosine, let u equal negative sine, right? So this will be u. Oh, actually, no, that's stupid. Sorry about that. This should be the other way. We never put u on the du on the bottom. It doesn't make sense. U should be sine. Du is right there. Cosine d dx. Alrighty, so this would be simply du over u squared, which gives us, let's see, negative 2 du, which is negative u, negative 1 plus c, which is really negative sine x, negative 1. Sorry, got carried away there. So add the power, divide by the negative, change it back to sine, which is really just, what is it, cosecant, right? Technically. Or 1 over sine. So that's all for 8.3. Guys have any questions on 8.3? Let's take a 5-minute break, and then we'll finish 8.4. So it's 9:03. Start up again at 9:10.
I got a question.
Yeah, what's up?
Did you ever figure out number 15 on the review?
No, I have not. I forgot about it. I forgot. Let me.
I was
I'll look
having
at it.
trouble on that one.
You're talking about the center mass? Is that what it was?
Yeah, the center mass.
So that didn't come out for you either.
Yeah, it didn't come up. I got like 87 over 50 or something like that. I don't remember. Yeah, but
Yeah, I think that's what I got to. Something close to that. Okay. I wonder if the answer key's messed up. I'll look at it more closely. It could be that they're wrong, because I was
okay.
hoping one of you guys would see an error in my stuff, but if no one's seen anything, I'm starting to wonder.
Okay.
Yeah, I felt like I was right too, but I always have doubts.
Yeah. Yeah, I know. I kept doubting. I'm like, this thing's been right, but I don't know. I just didn't know.
Yeah, I didn't see any errors in the process, but we'll look at it. But I mean, if your work is similar to mine, that would count it, right?
Yeah.
Because I mean, I didn't see any mistakes. But
Okay.
anyway, but yeah, I'll check it out again, and I'll let you know.
Okay.
All right, wait, give me 5 minutes. Wording on that one. Shoot. Example 2. Integral of dx over x squared plus 1. So 3/2. So we have scenario, I think that's 2. Let me see. Yeah. 2. So u is equal to x. My a is equal to 1. So x will equal to 1 times tangent, right? Dx will equal to the secant squared, d theta. If you draw your triangle out, just to have it all out of the way, at tangent equal to x, meaning that opposite over adjacent would be your triangle, and this would be, of course, x squared plus 1. So substitute. So it'll be the integral of secant squared on top, d theta, over tangent squared theta plus 1. All right. Tangent squared plus 1, though, is going to be, what is that? Secant squared. That should be theta. So the 1/2 would cancel with this guy, leaving you with an integral of secant squared theta over secant cubed theta d theta, which will leave me with an integral of 1 over secant theta d theta, which is really just cosine theta d theta, which is sine, right? That makes sense? And sine is defined as opposite over hypotenuse, so that would be x over square root of x squared plus 1 plus your c. So this is the actual solution. Our trig sub is just like a dummy variable. It's not the real solution, right? Is there any questions about any of these steps? All right, guys. Well, we'll stop here and we'll continue. Well, I'm going to open up the homework for chapter 8 because I forgot to do that last time. And we'll, if you have any questions next time, we can go over some. If not, we will go through 8.5. Stop here.